Hey guys, today I have a super quick and easy lesson about qualitative and quantitative analysis. So let's get into it. Okay, so when we're talking about qualitative versus quantitative analysis, what we're really going to be getting into is what the difference between those two types of analysis are, as well as the properties of both of them. We're going to look at some of the different processes that are involved in the data collection for those two types of analysis, and then how we use different senses for the qualitative analysis. So when you're analyzing chemical properties, really what you're looking at is the behavior of the chemical. So how it reacts, how flammable it is, what shape is it, how strong does it react, does it have different versions of the same chemical, which are called isomers, is it toxic, all those kind of stuff. It is important to know those different chemical properties so that you can store it and handle it and dispose of it properly. So you want to know what kind of chemicals it reacts vigorously with when you're storing it. You don't want to store it near something that it could react with. You need to know if it's toxic or corrosive or flammable when you are handling it. You need to know if it's going to cause some sort of environmental catastrophe if you just dump it down the sink, that kind of stuff. It's also important to know what to expect in our reactions, whether, it's important that if you're dealing with really most of the alkali metals, that if you put them in water, it's going to catch fire and explode. You also want to know how different versions of that chemical are going to act in the human body, that kind of stuff. So we gather information about chemical properties of a whole bunch of different substances using both qualitative and quantitative analysis. When we're talking about qualitative analysis, that is any type of analysis that you can describe in words, but not numbers. And we usually gather this information just by making observations and using our senses. So sight, hearing, touch, taste, and smell. So sight is obviously the biggest one. Normally when you're doing observations during some sort of experiment, you're looking to see if there's bubbles, is there smoke, is there steam, is there a color change, is there a spark or flames, is there a precipitate forming, all of that kind of stuff. Most of the evidence of chemical change is something that we detect visually. We can also observe color changes on pH tests. We can use flame tests to see what elements are present by comparing the color of a flame to like a chart. We look at substances under microscopes to see things that we normally couldn't see with the human eye alone. Hearing is a little tougher. We do sometimes hear bubbles escaping or small explosions or popping sounds during some chemical reactions, but this is more commonly used when dealing with radioactive decay and nuclear reactions where you involve like Geiger counters to detect that radioactive particle decay. With touch, sorry, had a phone call there, forget what I was talking about. I don't think I started this yet. So touch is obviously useful, but only in very specific circumstances because a lot of chemicals that you're dealing with are not necessarily safe to touch. Especially if you just don't know what the chemical properties are, then you definitely don't want to be touching it. However, sometimes physical properties can be determined with touch. Things like hardness, malleability, and ductility can be determined by touching things, even with gloves on. You can also identify bases sometimes with touch because you can feel that they're slippery. Again, you wouldn't want to do that with any strong bases that would corrode your skin off. The reason bases often feel slippery is actually because they're breaking down the fat and oil on your skin into a soapy substance. Smell is a really interesting one. Again, not all chemicals should be smelled directly. You always want to waft gently towards yourself. Some chemicals you don't even want to do that. There are chemicals that can damage or irritate the lungs. Some even cause permanent lung damage. and those are chemicals that should be used in a fume hood. But other chemicals are safe to waft towards you, and organic chemicals in particular have very, very strong odors. Esters, which are a class of organic molecules, tend to smell either fruity or minty. Amines, which are another class of organic compound, tend to smell really fishy. Things like hydrogen sulfide, which is a deadly gas, tends to smell like rotten eggs. Acetic acid smells very vinegary. So at the top here, we just have examples of a bunch of different chemicals that smell like specific fruit. When I was in university, we actually did a lab where we had to make a whole bunch of different chemical compounds and then identify their smells, and they're very distinct pineapple smells and stuff like that. On the other side here, we have two chemical compounds, one called putrescine and one called cadaverine. Cadaverine named after the fact that it smells like a dead body or a cadaver. And then putrescine smells putrid, as in gross. Those are also organic compounds. And then lastly, taste. Should never just go in and taste random chemicals. The chemicals themselves might not be safe, or even chemicals that seem safe might be cross-contaminated if they're in a lab. So you should never taste anything if you're not 100% sure what it is. However, naturally occurring substances that taste sweet are often non-poisonous, and bitter ones are often a sign of poison. You can also sometimes estimate pH with taste because acids tend to be sour and bases tend to be bitter. Again, only if you know that substance is safe, like if it's like lemon juice or vinegar or something like that. And then forensic scientists actually sometimes taste rocks to tell them apart. Mudstone and siltstone can apparently be differentiated on taste. Mudstone tastes creamy and siltstone tastes bitter, apparently. I would not want to have that job. So that's it for qualitative analysis. Now let's get into the quantitative analysis. So quantitative analysis involves using measuring instruments to gain information about chemicals. This always involves numerical quantities of some sort. So this includes anything like mass, volume, density, number of moles, molecules, or atoms, anything that you find using stoichiometry, so the mole ratio, freezing point, melting point, boiling point, solubility, literally anything that involves a number and that you can calculate would be a quantitative analysis. Okay, so that is it for that lesson. Like I said, super quick and easy, but let me know if you have any questions.